All right, we're going to be practicing balancing redox reactions again, this time again with basic solutions. Again, the majority of the balancing redox steps are going to be followed, just like you've done for other reactions. And then there's just an additional step at the end, really, for basic solutions. So we're going to ignore that basic part for now and figure that out at the end. So we're going to start by dividing into half reactions. So my first half reaction is Cr to CrO2 minus. My second is ClO4 minus. To my ClO3 minus. All right, so we've done that. Step 2, balance each half reaction. So we're going to start by balancing elements that are not ORH. So 1 Cr, 1 Cr, we're good. 1 Cl, 1 Cl, we're good. Now we're going to balance our O's by adding H2O. In our top reaction here, you're going to notice that we have no oxygens on the left and 2 on the right. So I'm going to go ahead and add my 2 waters over here. And then on the second reaction, 4 O's on the left, 3 on the right. So we're going to go ahead and just add a single water on the right-hand side. Next step, we're going to balance our H's by adding H+. So again, top reaction, don't forget to distribute. 2 times 2 is 4 H's on the left, none on the right. So I'm going to go ahead and add 4 H pluses over here. And for my other reaction, we have 2 H's over here on the right from our water. So we're going to add 2 H pluses over here. All right, next step is to balance my charges by adding electrons. Again, I think this is the step that for a lot of students is the one that gets them in trouble because they're not paying close enough attention to charges. So let's go ahead and take a look at this top one. If I take a look at my charges over here, on the left side, total charge is 0. On the right side, again, be really careful. I have -1 from my CrO2 ion and +4. So overall, it's going to be a charge of +3. And we know very well that when we balance these by adding electrons, we're going to add to the side that's the most positive because electrons are negative. So we're going to go ahead and add 3 electrons there so that we have a total charge of 0 on the right as well. In my next reaction, let's go ahead and take a look at charges there. I have 2 positives and a negative, so my total is +1. And over on the right-hand side, I have a -1 charge. So we want those to be equal. So since we're adding electrons and they're negative again, we're going to add to the side that's most positive. To make this equal to -1, we have to actually add 2 electrons. All right, so we balanced our charges. Step 3, we need to go ahead and multiply our reaction so that the electrons are equal. So this is a case where our electrons, we're not just going to be able to multiply one reaction, we're going to have to multiply 2. So I have 3 electrons in my top reaction, 2 in my bottom. To make them equal, we're going to make each of these equal to 6. So my top reaction is going to have to be multiplied by 2, and my bottom reaction is all going to have to be multiplied by 3. So again, I'm going to come through and write my new numbers and then rewrite my equations. So I've got a 4 here, a 2 here, a 2 here, an 8 here, and a 6 here. And for my bottom reaction, multiply by 3, I've got a 6 here, a 6 here, a 3, a 3, and a 3. And again, some people like to do it in their head at this point. I prefer to rewrite my reactions just so that they're a little easier to see for canceling. So I've got 4H2O plus 2Cr yields 2CrO2 minus plus 8H plus 6 electrons for my top reaction. And for my bottom reaction, I've got my 6 electrons plus 6H plus 3 ClO4 minus yields 3 ClO3 minus plus 3H2O. All right, so now that I have those 2 reactions written, we've done step 3, we're going to simplify and add our half reactions. So let's go ahead and simplify out. So first thing I love to cross out is my electrons because they should be the same. That was the point of step 3. And now I'm going to look for waters and H pluses. That's usually what I'm going to find. So I have 4 waters over here on the left and 3 on the right. This is going to be completely eliminated because there's fewer of them. This is only going to have 1 water remaining. Now my H pluses. I have 6 over here and 8 over here. This is going to be completely eliminated, and I'll be left with 2 H pluses over here. So if I rewrite my final equation, it's going to look like this: 1H2O plus 2Cr plus 3 ClO4 minus yields 2 CrO2 minus plus 3 ClO3 minus plus 2 H pluses. All right, so now that I've done that, This would be normally where I would stop if this was an acidic balancing reaction, but it's basic. So for basic, I have to do my one more step and cancellation. So I have to eliminate my H pluses by adding OH minuses to each side. So I'm going to change my color just so I can see that. So I look for my H pluses, they're right here. To eliminate them, I need to add 2 OH minuses. If there was a 4 there, I'd add 4 OH minuses. If there was a 7 there, I'd add 7. So I just want to make sure I add the same number of hydroxides as I have H pluses or hydronium ions. I do have to add to the left side as well, the same amount. And now we're going to go ahead and add these together. This is going to form 2 waters. And if we take a look at our left-hand side, let's go ahead and do our simplification right now. When I put these together, I get my 2 waters, and I have 1 water on the left. So that's going to eliminate this water, and I'm going to have 1 water left over here. So my overall reaction is going to look like this. Again, a long process, but as long as you follow the steps, you should be fine.